When you look up at the night sky, it feels endless. Stars, galaxies, clusters. Everywhere you look, the universe seems full of light. But here's the truth. Most of the universe is empty. And there's one place in particular that shows us just how unsettling that emptiness can be. It's called the Boötes Void. Astronomers also call it the Great Nothing. And once you understand what it really is, it will completely change the way you think about space. The story begins in 1981. Astronomer Robert Kirshner and his team were mapping galaxies, measuring how fast they were moving away from us and building a 3D picture of the universe. Normally, you'd expect to see galaxies sprinkled everywhere, clumped into clusters, connected by filaments, all woven into the giant cosmic web. But in one region, something went horribly wrong. Where thousands of galaxies should have been, there was nothing. Not just a small gap, not just a missing cluster. An entire region of space spanning 330 million light-years across was almost completely empty. To give you perspective, if you traveled at the speed of light, it would take 330 million years just to cross from one side to the other. When Kirshner's team first saw this on their maps, they thought their instruments had failed. They recalibrated, checked the data, and ran the numbers again. But the result never changed. They had stumbled across a supervoid, a hole in the universe so large it shouldn't exist. But the void isn't completely empty. Deep in its heart lies a spiral galaxy named MCG plus 0102015. Astronomers call it the loneliest galaxy in the universe. And that title is no exaggeration. This galaxy is cut off from its nearest neighbors by tens of millions of light-years of nothingness. If you lived there and looked up at the sky, you'd see almost no galaxies at all. You might believe you were completely alone in the universe. But here's the fascinating part. Despite its isolation, this lonely galaxy looks surprisingly normal. It has stars forming, it has structure, it even has a central black hole. This shows us that galaxies don't necessarily need neighbors to evolve. Still, its loneliness gives us a chilling thought experiment. If intelligent life lived in that galaxy, they'd have no way of knowing the universe is full of galaxies. To them, the cosmos would look empty. The galaxies inside the Boötes Void aren't scattered randomly. They form a strange tube-like structure running through the middle of the void, like a narrow highway of light through darkness. And here's the kicker. These galaxies don't just sit there. They move in coordinated patterns, almost as if they're gliding along invisible tracks. That suggests something is actively shaping this void, carving out the space and leaving behind a narrow corridor of survivors. It's too precise to be an accident. So how does something like this form? To answer that, we need to rewind the clock all the way back to the Big Bang. In the beginning, the universe was incredibly small and dense. Tiny random fluctuations in energy, called quantum fluctuations, appeared everywhere. Over billions of years, gravity amplified those tiny differences. Slightly denser regions pulled in more matter and became galaxies and clusters. Slightly emptier regions lost matter and grew into voids. That explains normal voids, but not Boötes. According to standard models, the biggest voids should be about 100 million light-years across. The Boötes Void is over 3 times that size. In fact, by our best math, voids this big shouldn't even exist in the observable universe. And yet, here it is. Which means either our models are wrong or something else shaped this void. Part of the answer might involve dark matter and dark energy. Dark matter makes up about 85% of the matter in the universe. It doesn't emit light, but its gravity acts as scaffolding that galaxies use to form. In voids like Boötes, there just isn't enough dark matter. Without that scaffolding, galaxies never formed in the first place. But there's more. Voids are also places where dark energy dominates. Dark energy is the mysterious force that drives the accelerated expansion of the universe. In regions with lots of matter, gravity can fight back. But in voids where matter is scarce, dark energy wins. That's why voids don't just sit still, they grow. The Boötes Void is actually expanding faster than the universe itself. It's like something is actively pushing matter away, making the void emptier over time. Some scientists even describe voids like Boötes as cosmic bubbles. Imagine a soap bubble floating in the air. The thin film creates pressure, balancing forces inside and out. Now imagine that bubble scaled up to 330 million light-years across. The boundary of the void might act like a pressure system, pushing on the galaxies around it. In fact, galaxy clusters near void edges often appear denser than normal, as if they've been compressed by the expanding void next door. It's a tug-of-war on the largest scales imaginable. But there's a deeper problem. Forming a void this size should take at least 15 to 20 billion years. The universe is only 13.8 billion years old. So how did the Boötes Void get this big, this fast? Some scientists suggest that voids can merge, like soap bubbles combining into larger bubbles. Others argue that dark energy might have been stronger in the past, accelerating the growth. But none of these explanations fully solve the puzzle. Right now, the Boötes Void is a direct challenge to our entire timeline of cosmic evolution. And here's the thing, it's not even unique. Astronomers have found other supervoids, some even larger. The Eridanus supervoid, for example, spans almost 1.8 billion light-years. The universe, it turns out, is even emptier than we thought. But Boötes remains one of the most striking examples because of its clean, spherical shape and the strange tube of galaxies threading through its middle. Here's where things get even weirder. Observations show that voids like Boötes contain magnetic fields stretching across hundreds of millions of light-years. That shouldn't be possible. Magnetic fields usually come from moving charges, like stars, plasma, or gas clouds. But voids don't have enough matter for that. And yet, the fields are there, connecting the remaining galaxies like invisible railroad tracks. Some theories suggest these might be primordial relics from the early universe. Others think dark energy itself might generate them. Voids are also perfect laboratories for gravitational waves. On Earth, we detect these ripples in space-time using instruments so sensitive they can measure distortions smaller than a proton. But waves traveling through dense regions of space get scattered and distorted. In a void like Boötes, they pass through almost untouched. That makes voids natural observatories for studying the universe's deepest vibrations, carrying echoes from the very birth of time. Step back far enough, and you see that the universe isn't random. It looks like a vast cosmic web. Galaxies form along filaments. Superclusters glow at intersections. And between those glowing threads stretch enormous voids like Boötes. These voids aren't accidents. They're part of the natural pattern, the sponge-like architecture of the universe. But their extreme size raises tough questions. Were they carved by quantum chance, by dark energy feedback, or by forces we don't yet understand? Here's a thought experiment. Imagine Earth had formed inside the Boötes Void. Our skies would be nearly black. Early astronomers would think our galaxy was the entire universe. The idea of billions of galaxies wouldn't even occur to us until very recently. Our whole worldview, our sense of scale, our science, our philosophy, would be decades behind. That's how much our place in the cosmic web shapes our understanding of reality. So why study a giant patch of nothing? Because the Boötes Void isn't just empty, it's active. It's a window into the forces shaping the universe. By studying it, we learn about dark matter, dark energy, and the cosmic web itself. It helps us test our models of gravity, challenge our ideas of cosmic timelines, and maybe even glimpse the universe's future. Voids like Boötes also remind us of how fragile and rare our position is. We live in a galaxy-rich region, surrounded by stars, clusters, and neighbors. But most of the universe isn't like that. Most of it is empty space. If life depends on complexity, then we're incredibly lucky to exist where matter clumped together instead of draining away. In the grand scheme, our cosmic address might be one of the most fortunate possible. The Boötes Void stretches across 330 million light-years of near-total darkness. It contains just a fraction of the galaxies it should. It challenges our models of how the universe formed. It raises questions about dark matter, dark energy, and even the structure of space itself. And yet, in its emptiness, it teaches us more about everything. We often imagine the universe as overflowing with stars. But the truth is the opposite. Matter is the exception. Emptiness is the rule. The Boötes Void is a reminder that most of reality is nothingness. And in that nothingness lies the greatest mystery of all.